So previously, when I was doing multiple linear regression analysis, interaction terms were kind of this weird thing for me that I really didn't like and that I would rather ignore, that I found difficult to interpret. So let's backtrack what I'm talking about. If we say we have a multiple linear regression, then we would have something of the form y equals an intercept plus b1 x1 plus b2 x2. So this one would be a model without an interaction term. So let's think, for example, x1 and x2 are two drugs. Y is some kind of outcome that's affected by this drug. And we have b1 is the effect of drug x1 on this outcome, and b2 would be the effect of drug 2. Now, if we say there may be a potential interaction between those drugs, then we have to add our interaction term, B3. And interactions can actually take different forms, but often we think about a multiplicative interaction. So let's do this in this case, and let's say x1 times x2 here for the interaction. And as I said previously, I would have rather said, okay, I look at this model without the interaction term, and then we have this relatively simple explanation of, okay, b1, as I said, is the effect of x1 on the outcome, and b2 is the effect, the slope of x2. Now, one reason also I think why interaction terms are generally unpopular is if you now think about extending this model, include x3, x4, and so on, then you need to include all these possible combinations between your variables, and then not just in terms of the product, not just the product between two of them, but also interactions between three of them, and at some point it gets very large. So I think this is why generally, not just me, but many other people also are not too keen on these interaction terms. Also, if you use R, for example, usually the way how you learn multiple linear regressions would be you use LM, and then you have Y as a function of x1 plus x2. And this one would be the model that does not have the interaction term. So this would be this part here without the x1 times x2 term. And as I said, I believe this is the way how we usually learn the linear regressions, and the interaction terms is something that's then usually just mentioned later on, in which case instead of the plus, you would have the star or the asterisk here. Now, as I said, okay, these models can become very complex if you think about having a lot of different variables. And in this case, it may be justified that you could say, okay, I don't need these interactions. If you're in a situation where you say, okay, I have these very many variables, I don't actually really know, do they have an effect on my outcome? Do they not have an effect on my outcome? Then it may be more justifiable to say, at least in a first step, okay, let's consider each on their own, and then maybe once we have a clear idea of what actually affects the outcome, then we think about these higher level terms. But in the scenario that I just described, you have these two different drugs, and you know that these drugs will have an influence on your outcome. So let's say these are drugs that both influence blood pressure, and you know that they both have this effect. Then I would argue that, you know, more likely than not, there probably will be an interaction between them if you know that they affect the same thing. Now, as I said, okay, I always thought, okay, this interaction term, that's also something that's difficult to interpret. So my question to you is now, if I have this complete model, including the interaction term, how do we interpret the effect of drug X1? So let's be more specific, X1 here could be the concentration of our drug X1. How do we interpret the effect of this drug concentration on the outcome? And if you just think about it very quickly and maybe a bit naively, then you would still say, well, this B1 here, the slope on X1, that's the effect on drug x1. The correct answer is the effect of drug x1 now obviously depends, and it depends on the presence on x2 and the level of x2. And a relatively simple way of thinking about this, at least if you only have these two variables, is you can change the equation. We still have the intercept here, but then you simply say, okay, we take the terms of having x1 together. So this would be this term here. So b1, and then you take the other term that has x1. So we take b3, x2, and then we just take x1 outside. And then we have this term here remaining. So plus b2, x2. And now we still have a relatively simple way of interpreting what's the effect of drug x1 on our outcome, on our blood pressure, let's say. And it's simply this term here. And this term tells you exactly what it should tell you. The effect of the drug x1 depends on the amount of x2 that's present. So I hope that's helpful in getting a bit of a better feel about these multiple linear regressions.